Okay, let's start off with the first section. What is SQL injection? SQL injection is a vulnerability that consists of an attacker interfering with the SQL queries that an application makes to the backend database. So if you as an attacker can manage to interact and change the SQL query by adding SQL characters or SQL code in an input vector of an application, then the application is definitely vulnerable to SQL injection. Now, to better understand this, let's take an example. Imagine you have an attacker, a web server, and a database. The application that the web server hosts has an authentication functionality where the user has to put in their username and password. And once the username and password are put in, a query is made to the database to see if this username and password are in the database. And if they are, then the user is presented with his or her profile page. If the user enters an incorrect username or password, then the user is presented with an error message that says you have entered an incorrect username or password. So in this case, we clearly have two input vectors, the username field and the password field, that talk to the backend database. So they get included in a query in the backend database. And so we definitely need to test these input vectors for a SQL injection vulnerability to see if that input is validated in any way. So let's see what an attacker can do. In this case, what an attacker is doing is in the username field, instead of just adding a username, the attacker adds the username admin, the account that the attacker wants to compromise. But then the attacker also adds some SQL characters after the username. So a single quote and then a double dash, which stands for a comment. So what happens is that this username gets included in a query. So what the query does at the backend is it says select star from users. So select all the entries from the users table where username is equal to whatever username is put in here and password is equal to whatever password is put in here. Now, if this input is properly validated, and we'll talk about that in the next couple of sections, if this input is properly validated, then the database will literally look for a username that is equal to admin code -- in the database. And it won't find one because no one has that username. And so the attacker would be presented with an incorrect username or password. However, if this application is vulnerable to SQL injection, so it doesn't use parameterized queries, it doesn't validate user input, then what will happen is that any SQL characters or SQL code that the attacker adds as part of the payload will become part of the query. And so in this case, what's happening is select star from users. So select the entries from the users table where username is equal to admin. The single quote over here that the attacker included closes the string for the username, and then the double dash stands for a comment, and so it says comment out the rest of the query. And so what happens is the query becomes this. So select all the entries from the users table where username is equal to admin. Now admin is an existing username in the database, and so what happens is that the database will return the admin user profile, and the attacker gets logged in as the admin user. So essentially what happened over here is that the attacker exploited a SQL injection vulnerability in the login functionality of the application in order to bypass authentication. So in this case, the attacker no longer needed to know the admin's password because the attacker was able to change the query to no longer ask for the admin's password. So that's one example of how you could use SQL injection vulnerabilities in order to bypass authentication on login functionality. Now, let's talk about what are other impacts of SQL injection attacks. And the real answer to this is that it really depends on the context of the SQL injection that you're exploiting. So some SQL injection vulnerabilities will only allow you to view data, whereas others will allow you to actually modify data. So when I was coming up with this slide, instead of listing the infinite number of things that you could do to applications with SQL injection vulnerabilities, I instead decided to just compare it to the SIA triad, so how it affects confidentiality, integrity, and availability. So in terms of confidentiality, some SQL injection vulnerabilities will allow you to view sensitive information, such as usernames and passwords, so the application's username and password. And that's an example of how you impact the confidentiality of an application by accessing information that you shouldn't have access to. In terms of integrity, some SQL injection vulnerabilities will allow you to alter data in a database. And an example of that I exploited not too long ago is an application that allows you to update an email address. And so because this was vulnerable to SQL injection, I was able to update another user's email address to one that I control. And so what I did is, because I control this email address, I reset the password of the user, and the reset token was sent to the email address that I own. And so I hijacked the user's account. And that's an example of how to affect the integrity of the application, because you were able to alter data that you shouldn't have otherwise been able to alter. It also affected the availability of the application, because I denied, when I reset the user's password, I denied access to the user's account. And so I affected the availability of the application. And of course, in certain scenarios, SQL injections could actually lead to remote code execution on the operating system, and that affects confidentiality, integrity, and availability all at once. And you would gain access to the operating system with the same privilege that the database is running with. And so you got to be very careful in terms of making sure that the database runs with the least privilege possible. And we'll discuss that in the last section when we're talking about things like defense in depth and how to prevent SQL injection vulnerabilities. Okay, so we talked about the impact of SQL injection vulnerabilities. Now the question is, how common and how critical are SQL injection vulnerabilities? And one way to measure that, and it's not bulletproof, is the OWASP Top 10 list. So for those of you that have never heard of the OWASP Top 10 project, it's essentially the list of top 10 most critical security risks to web applications. It's updated every couple of years. So you could see over here, I've got the 2010 list, the 2013 list, and then the 2017 list. And you'll notice over here, it does change across the years. So you've got cross-site scripting was the second most critical risk to web applications in 2010. And then it became the third most critical risk in 2013. And then it dropped all the way to the seventh most critical risk in 2017. And you'll see some of them completely disappear. So insufficient transport layer protection was number 9 of most critical risks in 2010. But it completely disappeared in 2013 and 2017. And that's probably because it's so easy to now get certificates and use HTTPS on your site. Even malicious sites use HTTPS right now, so it's definitely not a risk anymore. But then you see also new ones get added. So for example, insecure deserialization over here was never a risk in 2010 or 2013, was not part of the list. And in 2017, it became part of the list. Now for SQL injection vulnerabilities, they fall under the first most critical risk to web applications. So they fall under the injection category. However, it's worth mentioning that this covers all of injection vulnerabilities, not just SQL injection vulnerabilities. In fact, the likelihood of SQL injection vulnerabilities existing in applications has decreased across the years for many reasons, and we'll discuss that in the last section when we discuss how to prevent SQL injection vulnerabilities. Nevertheless, it is still a critical risk because, as we saw in the past couple of slides, if you do have even just one parameter that is vulnerable to SQL injection, it could potentially lead to remote code execution on the server, so a full compromise of the underlying server. All right, so in the past couple of slides, we got a high-level overview of what SQL injection vulnerabilities are. Now we're going to go at a more granular level and talk about the different types of SQL injection. SQL injection vulnerabilities can be classified into 3 major categories. The first is in-band or classic SQL injection. The second is inferential or blind SQL injection. And the third is out-of-band SQL injection. Now, in-band, or also known as classic SQL injection vulnerabilities, are ones where the attacker uses the same communication channel to both launch the attack and gather the results of the attack. If that doesn't make much sense to you, that's okay, don't worry. I actually have a couple of slides explaining each type in detail. Right now, I'm simply giving you a high-level overview of what each type is. Now, in-band, or classic SQL injection, is divided into 2 types: error-based SQL injection and union-based SQL injection. Error-based SQL injection is a technique where you force the database to generate an error, giving you more information about how things operate at the back end. So an example would be if you have a parameter that is vulnerable to SQL injection, and then you put into that parameter a single quote, and that breaks the backend query, which generates an error at the application level. And so what happens is that the error tells you things like the version of the database, so the type of database that they're using at the backend, the version of the database, and sometimes the error will also tell you the exact SQL query that is being used at the backend. And this would make your life so much easier because if you know the exact query, you don't have to guess it using trial and error. And this way you could just build your SQL payload. So that's an example of error-based SQL injection. For union-based SQL injection, it's a technique that leverages the union operator to combine the results of two queries into a single result set. So in this technique, you don't just output the result of the original query that the application makes, but you also output the result of a query of your choosing. And of course, something that you would be interested in is, for example, the usernames and passwords of the users of the application. So you would use the union operator to output the credentials of the users of the application. And again, we'll see examples of that in the next coming slides. The next category, which is inferential, or also known as blind SQL injection. In this type of vulnerability, there's no actual transfer of data via the web application. So you don't see the results in the application itself. Instead, you're stuck asking the application true or false questions, which is what Boolean-based SQL injection is, or causing the database to pause for a specified period of time, which is time-based SQL injection, in order to determine if what you're asking the application is correct or not. Obviously, the way you exploit blind SQL injections is more difficult than classic SQL injections. However, the impact, even if you're not seeing the results right away in your application, the impact of exploiting the vulnerability is still as bad as in-band or classic SQL injection. And we'll see examples of that in a bit. Okay, the third and last category is out-of-band SQL injection. This occurs when the attacker is unable to use the same channel to launch the attack and gather the results of the attack. It usually relies on the ability of an application to make a network connection, so for example, a DNS or HTTP request to deliver data to an attacker. I've seen people loop this type of SQL injection under inferential or blind SQL injection, which is a fair thing to do. However, if you look at resources online, most of the resources out there will separate them into 3 different categories, and that's why I decided to also separate them into 3 different categories in my video. Okay, let's go more in depth about each type, starting with in-band or classic SQL injection. We talked about in-band SQL injection vulnerabilities occurring when the attacker is able to use the same communication channel to both launch an attack and gather the results of an attack. So to put this in plain, simple English, if you exploit a SQL injection vulnerability by sending a SQL payload in one of the fields of an application, and then you see the result of your SQL payload presented directly to you in the application, then this falls under the category of in-band SQL injection. Now, just by the nature of how this specific type of vulnerability works, it's much easier to exploit than other categories of vulnerabilities. And the reason behind that is because you actually see the result of your attack in the response of the application versus having to infer the result like you would have to in blind SQL injection. Again, we said that there's 2 types of in-band SQL injection, error-based SQL injection and union-based SQL injection. And we'll start off with error-based SQL injection. Error-based SQL injection is an in-band SQL injection technique that forces the database to generate an error, giving the attacker information that could potentially aid in developing the injection payload. Let's take an example. Imagine you have an application, www.random.com, that has an ID parameter that is vulnerable to SQL injection. In this case, we're putting a single quote in the ID field, and because that is a SQL character and this is vulnerable to SQL injection, that single quote will become a part of the query, and so it'll break the backend query and it'll output an error. And an example error is you have an error in your SQL syntax, check the manual that corresponds to your MySQL server version, blah, blah, blah. So in this case, it tells you that you're using MySQL. That's good information to know. It might also tell you the version. And again, in certain scenarios, the error might also give you the query that happens when you put an ID parameter. So what's happening when you put for example, an integer in the ID parameter, the exact query that happens at the backend. And this way, if you have the exact query, it's so much easier for you to develop your payload versus sending a bunch of requests to the application in order to determine what the payload is. And so this is in-band SQL injection or classic SQL injection because you see the output of your SQL injection right there in the application. Next, we have union-based SQL injection. Union-based SQL injection is a type of in-band SQL injection technique that uses the union SQL operator to combine the results of two queries into a single result set. Again, I mentioned in the previous couple of slides that I don't want to output just the result of the original query. I want to output a query of my choosing. And if an application is vulnerable to union-based SQL injection, then I get the ability to output the result of a query of my choosing and combine it with the original query that the application is, with the result of the original query that the application is making. Let's take an example. You have your application, www.random.com. It has an ID field that is vulnerable to union-based SQL injection. And if you put in a valid ID, then the page will display all the products that are associated to that ID. And now instead of just displaying the products associated to a specific ID, I want to output the results of another query. And in this case, the query is select the username and the password from the users table. So output all the usernames and passwords from the users table and then comment out the rest of the query. So in this case, it will output the results of this query over here. We didn't put an ID in, so that would be empty. And then it'll combine it with the results of this query over here, which is the usernames. So Carlos, an administrator, and the passwords of the users in the users table. Now, of course, the union operator has certain conditions for it to work. And so it's not as simple as, hey, I'm going to output whatever I want in as many fields as I want. Instead, there are certain conditions that you have to follow, and we'll discuss that in the exploitation section of this video. Okay, so that covers in-band or classic SQL injection. Next, let's talk about inferential or blind SQL injection. Inferential or blind SQL injection is a SQL injection vulnerability where there's no actual transfer of data via the web application. So unlike in-band SQL injection, where we directly saw the output of the SQL injection displayed for us in the application, in the case of blind SQL injection, the database does not output data to the web page. And so this forces the attacker to steal data by asking the database a series of true and false questions, and then determining based on how the application responds, whether the application responded with, yes, this is a true statement versus no, this is not a true statement. And again, this will become more clear once we discuss the different types of blind SQL injection and we take examples. Now, just because an attacker can't directly display data from the database, that doesn't mean that this is a harmless vulnerability. Like I said in the previous slides, in fact, it's just as dangerous as in-band SQL injection because you can extract information from the database by asking true and false questions. It's just that this type of vulnerability takes a little bit longer and a little bit more skill set in order to exploit. Okay, and we said there are two types of blind SQL injection, Boolean-based SQL injection and time-based SQL injection. Let's talk about Boolean-based SQL injection. Boolean-based SQL injection is a blind SQL injection technique that uses Boolean conditions to return a different result set depending on whether the query returns true or a false result. So in simple English, again, the attacker sends different SQL payloads that ask the database true and false questions. And depending on how the database responds, then you could infer whether the application responded with true or false. This is sometimes referred to as content-based blind SQL injection. So you'll see those two terms used interchangeably. Now, let's take an example so that this becomes a little bit more clearer. Imagine, again, you have an application, www.random.com, and it has an ID parameter that is vulnerable to blind SQL injection. And imagine in this case, you can't simply use the union operator to output data in the database like we did with union-based SQL injection. So in this case, what you can try to test if the field is vulnerable to SQL injection is first inject it with a false payload. So force a payload that you know is false, and then see how the application responds, and then force a payload that you know is true, and see how the application responds. And if the application responds differently in the false payload versus the true payload, then this is vulnerable to Boolean-based blind SQL injection. So let's take the backend query. So imagine over here, when you enter an ID number, this is a query that happens at the backend. So select the title from the product table where ID is equal to 1. And because ID is equal to 1 is a valid ID in the table, the application will display the title of the products that are associated to ID 1. Now, if we want to force a false payload, what we can do is we could use a conditional statement and 1 is equal to 2. So the backend query would be select the title from the product table where ID is equal to 1 and 1 is equal to 2. Now we said ID is equal to 1 is a valid ID, and so this will evaluate to true, and 1 is equal to 2 will evaluate to false because 1 will never be equal to 2. And so because this is an AND statement over here, they both have to be true in order for the entire where clause to evaluate to true. So this evaluates to true, this evaluates to false. True and false is equal to false. And so the entire where condition evaluates to false. And so it won't display a title from the product table. So in this case, if you force the false statement, you won't get the title of the products that are associated to ID is equal to 1. Now let's see what happens when you force a true statement. So we'll use conditional statements and we'll say ID is equal to 1 and 1 is equal to 1. Now we said ID is equal to 1 evaluates to true because this is a valid ID in the table, and 1 is equal to 1. 1 will always be equal to 1, and so this will always evaluate to true. True and true evaluates to true, and so the where clause evaluates to true, and so the title of the products that are associated to ID 1 will be outputted on the page. And so right now, I have two different responses depending on whether I force a false statement versus a true statement. And so I'm able to tell when the application is telling me, yes, this is a true statement versus no, this is not a true statement. And so now you might be wondering, well, it's nice that I can play around with the application and get it to output true or false, but how does that actually matter? And how does that help me in exploiting a SQL injection vulnerability to get sensitive information from the database? To answer that, let's take another use case. So imagine the same application. The application has a login functionality, and so it has a users table in the database, and the users table has the usernames of the users of the application, so in this case, administrator, and the hashed passwords of the users in the application. And so I want to extract this hashed password for the administrator, but I can't simply output it on the page like I would for union-based SQL injection. And so I have to use my Boolean-based SQL injection in order to output it. And that's only done by asking the application true and false questions. And so the way I'm going to do that is by using this payload over here, which generates this query over here. I'll use the substring function. And what that function does, it extracts some characters from a string. So the first parameter that it takes is the string that you want to extract from. The second parameter that it takes is the start position for the extraction. And the third parameter that it takes is the number of characters to extract. So in this case, I'm saying that string to extract from is the output of this query. So select the password from the users table where username is equal to administrator. This query will output this hashed string over here. And then I'm asking it extract the first character in the string and only one character. And so it will extract the first character over here of the hashed password. And then I'm asking it, is this first character equal to S? In this case, the first character is not equal to S because the first character is E. And so this statement over here evaluates to false. True and false evaluates to false. And so the where clause evaluates to false, and you shouldn't see a title from the products page. And so nothing is returned on the page. That means it returned false. That means I know that S is not a first character in the hashed password. Now, imagine I keep looping through the characters and I get to E and I ask it again, is the first character of the hashed password equal to E? That evaluates to true, right? So the backend query would be true and true. So the entire where clause evaluates to true. And so the title of the products that are associated to ID 1 are returned on the page. And this gives me an indication that it returned true, which again tells me that E is the first character of the hashed password. Right now, you should get an indication of how you're going to extract information from the database and why I said it takes more skill set and more time than union-based injection. And that's because you're asking the application true and false questions, and you're going to have to do that for each character. So you start off with the first character, you loop through all the alphanumeric characters until you get a true result. Once you get a true result, that means you know you discovered what the character is, which is E over here. And then you move on to the next one. And then you loop through the alphanumeric characters until you get another true statement. And then that means you discovered what this character is. And then again, you loop through all the alphanumeric characters until you discover what this character is, and so on until you output the entire string of the hashed password. And this could take thousands of requests. Obviously, you can't do it manually, and so you have to automate the task. And we'll do that in one of the videos where we use Burp Intruder. To automate it, we'll also write a Python script that does it for you. And it might seem like it's something that is very difficult, but it's not. Writing the script in Python takes about 5 minutes, 5 to 10 minutes max. And then outputting the string is going to take less than 1 minute, outputting the entire hashed password. So that's Boolean-based blind SQL injection. Next, let's talk about time-based blind SQL injection. Time-based SQL injection is a blind-based SQL injection technique that relies on the database pausing for a specified amount of time, then returning the results indicating a successful SQL query execution. So just like we did for Boolean-based SQL injection, what we do for time-based SQL injection is we inject a payload in the parameter that is vulnerable. And what that payload does, it pauses the application, the response of the application for a certain period of time. So in PostgreSQL, you would use the pgsleep command and input a certain number of seconds. So if I use pgsleep 10, that means I ask the application to sleep for 10 seconds. And so if the response time takes 10 seconds to get back to me, then I know it's vulnerable to time-based SQL injection. If it doesn't take 10 seconds, so it takes the general 1 second to get back to me, then it's not vulnerable to time-based SQL injection. And the example is the same for Boolean-based SQL injection. The way you would extract information from the database is by asking the application true and false questions, except the condition over here is not a response in the application. The indication of whether it's true or false is going to be based on the response time of the application. And so I'm going to say if the first character of the administrator's hashed password is an A, then wait for 10 seconds. And if the response time takes 10 seconds to respond to me, then the first letter is A. If it doesn't take 10 seconds, then the first letter is not A. And again, this can't be done manually. You're going to have to script it, and you can do that in Python where you measure the response time. And then depending on what the response time is, you determine whether it's true or false. Okay, last but not least, let's talk about out-of-band SQL injection. Out-of-band SQL injection is a vulnerability that consists of triggering an out-of-band network connection to a system that you control. So this technique is usually used when you can't apply any of the other techniques that we learned about so far. And it's not a common technique because it does rely on certain features being enabled in the database for it to actually make that network connection. Now, to exploit this vulnerability, you could use a variety of protocols, but you'll see that the most commonly used ones are DNS and HTTP. And one that we will look at in the videos, it's in the Web Security Academy. So in the upcoming videos where we gain hands-on experience doing this, is this example over here, where you exploit the vulnerability by using the XPDIR tree stored procedure in MS SQL to perform a lookup of this domain over here. So this domain was generated using Burp Collaborator, and so you own it. Since this is the domain that you control, you can confirm if there were any DNS lookups. If there was, then this is vulnerable to out-of-band SQL injection. And if it's not vulnerable, then you won't see the DNS lookup. We'll see how to do this in the lab videos. Now, once you've confirmed that you have an out-of-band SQL injection, in some cases, you might be able to directly exfiltrate data, whereas in other cases, you might have to use conditional statements like we did with Boolean and time-based SQL injection, where if you do get a DNS lookup, then yes, this is a true scenario. If you don't get a DNS lookup, then no, it's not a true scenario.